Okay, this is a continuation of the practice test for Precalculus, Chapter 12. We are on to problem number 18. And in number 18, we have the same set of instructions that we had for number 17. They want you to find the sum of the sequence. They describe the sum here. They want you to start at a k value of 3. Take that all the way to a k value of 5 and use this formula. K squared plus 10. Okay, so when you're letting k be equal to 3, the very first value that they want you to use in the summation, it would be k squared plus 10. So that's 9 plus 10, or 19. Then the next value would be when you let k be equal to 4. So that would be 4 squared using this formula once again, plus 10. And that's 16 plus 10 is 26. Then we're going to go all the way up to a k value of 5, and we're stopping there. So a short summation. We're going to go k squared plus 10 as we have for the last two terms. And that's going to be 25 plus 10, 35. And then you just sum all of these together. It's the 19 plus the 26 plus the 35. You can go ahead and put that into your calculator, and the answer would be 80, which I believe was choice D. Okay, moving on to number 19. Same type of problems, last one under that set of instructions. They give you a sum this time that starts at 1 and spins to 4 and uses this formula. 1/4 raised to a different power each time, and that power will be the k value. So when you're letting k be equal to 1, then you have negative 1/4 raised to a power of 1, which is just negative 1/4. Then the next time it's going to be negative, so I'll write these down here, what they look like after you raise them to the power. This is for k equal to 1. This just turns out to be 1/4. Then the next term would be for k equal to 2, 1/4 raised to a power of 2. So that would be negative 1 squared, which is just 1. So you're going to raise the negative 1 to a power of 2. So that means negative 1 times negative 1 are just 1. And you're also going to raise this denominator to a power of 2. That would be 4 squared, or 16. Anything to an even power is positive. Okay, then the next thing, our next term that you're going to get is k equal to 3. So it's going to be negative 1/4 raised to a power of 3. So you're using this on the top as well as the bottom. Once again, you're doing negative 1, sometimes to an even power, sometimes to an odd power. That is what makes the sign on each of these terms alternate, positive, negative, positive, negative. So when it's raised to an odd power, it would just be negative. And then 4 to the third is 64. You're going all the way to where you're allowing the k value to be 4. So now moving to that term, it would be negative 1/4 raised to a power of 4. So that power gets used on the top as well as the bottom. So negative 1 to an even power is just positive 1. And then 4 raised to the 4th power is 256. Okay, then I would use my calculator to help you with these fractions. You're going to give your answer as a fraction. So the sum of all these fractions is negative 1 divided by 4 plus 1 divided by 16 minus 1/64 plus 1 divided by 256, and then instead of hitting enter, there's all my fractions, negative 1/4, positive 1/16, negative 1 over 64, and positive 1 over 256. Hit math, enter, enter, and it'll reduce the whole thing for you. So the final answer there is negative 51 over 256, where it's been simplified. Everything's been given a common denominator by way of your calculator, and it's been reduced by your calculator. Okay, that choice was, let's see, that would be choice B. Okay. Okay, moving on to number 20. Problem number 20. It says determine whether the sequence is arithmetic. So now, once we go to number 20, I believe numbers 20 through 30 are from section 2.2. Okay, so we've moved into the formulas from that section. Let me just put that here. And now we're in section 12.2, and this would be for numbers 20 to 30. Okay. And then let's start with number 20, where they give you a sequence, and they want to know if it's arithmetic or not. So it's 5, negative 15, 45, negative 135, and 405. So remember, if it is arithmetic, you should have a common difference. Common difference, a common difference meaning you're either adding the same value or subtracting the same value. Because subtraction can be thought of adding a negative. So we call this the common difference. Let's see what happens as we go from here to here. Well, if you had 5 and you wanted to end up on this number, you'd have to subtract 20. Well, the only way that this will be considered arithmetic is if that same 20 is being subtracted to get from number to number to number. And of course it's not. To get from negative 15 to 45, you'd have to add something different. Okay, if you were trying to get from negative 15 to 45, you would have to add 60. Okay, notice that this number is not the same as this, and therefore there is no common difference in this problem. So it's not arithmetic. And that's because there's no common difference. If you were adding or subtracting the same number each time to get from number to number to number to number, then it's arithmetic. So this one is not. Okay, so for 20, the answer is B, not arithmetic. Moving on to 21. Okay, again, we're in numbers 20 through 30, and those have to do with section 12.2. Okay, so for number 21, we have 2, 6, 10, 14, and 18. And we want to know, under the same instructions, is this an arithmetic sequence? So as you go from here to here, you'd have to add 4. As you go to here, from here to here, you'd have to add 4. Check at least 3 of them, and you can be sure that it's either one type of sequence or another. This is arithmetic. since there's a common difference. This is your D value right here, and so you can see it's the same one each time. Since there is a common difference. Okay, so the answer here was A. Yes, it's arithmetic. Okay, going to number 22, the directions change slightly. In 22, you can see on your practice test that it says an arithmetic sequence is given. Okay, so this is an arithmetic sequence is given. And then what they want you to do is find the common difference and write out the first 4 terms. Okay, so in this particular problem, all you're going to do is write out the first 4 terms, and then you can tell what the common difference is just by listing each of the first 4 terms. So you get the first 4 terms by letting n be equal to 1. You would get 8 plus 7, 15. This is when you're letting n be equal to 1. Okay, and then next one would be n equal to 2. So this would be 16 plus 7. I'll move this down just to make it a little nicer. Okay, so we have 15. This one would be 16 plus 7, which would be 23. So we have 15, we have 23, then it would be 8 times 3 plus 7 for the third value, and that would be 24 plus 7, which would be 31. And then the fourth term will be 8 times 4 plus 7. This would be 32 plus 7, or 39. So I've given the first 4 terms in the sequence, and then the common difference is just the number that it takes as you jump from number to number to number. What do you have to add or subtract to get from one number to the next? So what you have to add to get from here to here would be 8. Okay, then, so to get from there to there, it would be 8. And then notice that to get from here to here would also be 8. Add 8 to that and you get 31. Add 8 to that and you get 31. So that common difference is 8. So I've answered both questions there. Okay, moving to 23. And let's see, what choice was this? For number 22, this is B. Okay, then for 23, for 23, it's A is equal to 92. D is equal to -6. And then they want to know the nth term and the 6th term. Okay, so for number 23, okay, so when you go into section 2.2, one of the main formulas that you're looking at to do a lot of the problems in that section is this formula for the nth term. It's called the nth term formula. And this is for an arithmetic sequence, because you don't find the nth term the same when it's a geometric sequence. That has its own formula. So the nth term in an arithmetic sequence is like this. The nth term is the first term plus n minus 1 times d. This a that they're giving you, that is the same thing as the first term. Okay, so when you go nth term is equal to the first term, they gave you that, plus n minus 1 times d. So this is 92, and then this is going to be negative 6n plus 6. And you can write it however you want to. You can write the number first. I mean, you do have to combine like terms. Combine this with this, and that is equal to 98, or you can write the n term first. It doesn't matter. So that is your formula for the nth term. You can find any term in the sequence this way by using this right here. So let's see. What else did they ask for here? In this particular set of instructions for number 23, it said find the nth term. So we did that. And it also said find the sixth term. Those were the things in the instructions. So like I said, this formula that we've just come up with, you can find any term. So I'm going to use this to find the sixth term. I'm going to let n be equal to 6. Likewise, on the other side, it'll just be minus 6 times your n value, which is 6. So this ends up being 98 minus 36, which is 62. So this is the sixth term using the nth term formula. And the nth term formula, again, is always based on the first term, which they gave to you, and the common difference, which they also gave to you in this problem. Okay, moving on to 24. Let me get something else to write with here. Okay, number 25. Okay, so again, we're in section 12.2. Those are where the formulas are coming from. In number 25, it says for this one that the ninth term of the arithmetic sequence, and then they tell you what the arithmetic sequence is. Oh, no, they don't tell you that. I'm looking at number 24. So the ninth term of the arithmetic sequence is negative 68. And then they say the 15th term is negative 122. And then the questions end up being, find the first term. They want to know what is the first term. That's what it says in the instructions. And then they want you to give a recursive formula for this arithmetic sequence. Give a recursive formula, which means you're going to tell everyone how to find each term in the sequence based on a previous term. Okay, so we do have the formula that controls most of the problems in this section, which I just brought up in the last problem, and I'm going to keep writing them over and over again so you can have a shot at memorizing them. And that is the nth term is equal to the first term plus n minus 1 times the common difference. So I'm going to start off right there. And then what I'm going to do is I'm going to work with that ninth term information. You can work with the 15th term. We're eventually going to have to use both. But right now, I'm going to work with the ninth term information that they gave me. They said that the ninth term, I eventually will plug in that negative 68 right here. That will be equal to the first term. And if we're talking about the ninth term where your n value is equal to 9, then you should put the 9 right here as well. Okay, and then I can also find out the common difference because I can take into consideration that as I go from negative 68 all the way to negative 122, I'm going from the ninth term, I'm going to reason things out a little bit here, the ninth term to the 15th term. So think about how many terms, how many spaces are you moving as you go from the ninth term to the 15th term. Okay, you're going to the 10th term, the 11th term, the 12th term. If you count up how many terms there are between here and here, 10th term, 11th term, 12th term, 13th term, 14th term, 15th term, you are moving through 6 terms or 6 spaces, all the way through 6 terms. Well, the difference between these two numbers right here, negative 122 and negative 6, let's figure out what the difference is between these two numbers. You could go negative 122 minus the previous number, which is negative 122 plus 68, and you end up finding out that there are 54 numbers between the 9th term and the 15th term. Okay, that negative 54 is split up amongst 6 terms. So the jump, or the common difference each time, is negative 54 divided by 6, which is negative 9. This is your D value. So when I go to finish this right here, I'll put the 9th term. They told me what the 9th term was, negative 68. First term I don't know, but I'm about to find that out because that is one of the questions here. I wanted to put a D value right here, and I now know what that D value is. It's negative 9. So this is going to be, and I guess I can just put one sign here instead of 2. I'm going to have positive, but then this is 8 times negative 9, which is positive and then followed by a negative would just be a negative. Plus negative is just one negative. So now this allows me to figure out what a sub 1 is and answer one of the questions. It also will help me to figure out what the recursive formula is. But again, the hardest part of this problem is this part right here. They're going to give you 2 values that are in specific locations. This is in the 9th term position. This is in the 15th term position. So with respect to terms, that's what this is about, this 6. As you go from 9th position to 15th position, your 10th, 11th, 12th, 13th, 14th, 15th, and 16th. Oh no, you're only going to the 15th term. So there was, you're going to the 10th term, the 11th term, the 12th term, the 13th, the 14th, and the 15th term. And if you count that out, that's 6 spaces or 6 terms. And so what I'm spreading out is how many values occur amongst those 6 terms. So I just went negative 122 minus negative 68, which was a total of 54. And then I took that negative 54 and split it up amongst 6 terms as you go from the 9th position to the 15th position. So that's negative 9 for that common difference. And you can even use that right now. So first let's finish this. I needed that D value that I found right now so that I could finish off this formula to create this equation. And now I'm going to add 72 to both sides. And I have a sub 1 is negative Negative 68 plus 72, which is 4. So I've answered one of the questions, which is what is a sub 1? And now I'm going to answer this other question about giving a recursive formula. Well, if you want to give a recursive formula, you can just list the elements of the sequence. Okay, first term, 4. Common difference as I go from one term to the next is to subtract 9. So I'm going to go from here to here, subtracting 9. 4 take away 9 is negative 5. Okay, now I'm going to go from this term to the next term, subtracting 9 again. And when I subtract 9 again, I hit negative 13. So you see you can list the terms of the sequence. Oh, this was 14. So negative 9 combined with negative 5 is 14. So you can list the terms of the sequence, and you can go, you can list more of them if you want to, but I think you're ready to do a recursive formula. If you subtract 9 again, then this combined with this would be negative 23, and you have some of the terms listed. Not that you have to list this many. All right, so if you wanted to give a recursive formula, you could just go any term in this sequence, any term in the sequence of these values that I've listed here. Notice that all I was doing was using the common difference here to jump from one number to the next. I had already figured out what the first term was. It was 4. Then I kept subtracting 9 to move from term to term to term. This is going to allow me to write a recursive formula. A recursive formula that if you want to find any term in this sequence, all you have to do is take the previous number, which, like for instance, when you're moving from here to here was 4, and then subtract 9. So use the previous term and then subtract 9. And this gives you a recursive formula. Recursive formulas are all about how to find any term in the sequence using the previous term. N minus 1 is the term before the one you're looking for. So you could find this one right here using this formula. You could find this one using this formula. And look, it actually works. If you were going to take, let's say you wanted to find that right there. You would use the previous term, which would be 4. 4 take away 9, negative 5. Let's say you wanted to find this one. You would take the previous term, negative 5, and then subtract 9, and you would be at negative 14. So this formula, this recursive formula, allows you to find any term in this sequence, but recursively. Okay, we used this this formula right here. This is the formula for finding the nth term in an arithmetic sequence. And this is your recursive formula now that you know the d value. Oh, that's 25. Okay, moving to 26. In problem 26, let's see. And let me see which choice that was. I was trying to give you, as we went along, what the answers were. So this was choice A. I don't know if I gave you that for 24 or not. Let me see if I even did that one. Hold on 1 second. So I did number 20. I might have skipped 24. Let's check this out. Okay, so think I just numbered them wrong, maybe. Okay, so 25. The 9th term was negative. This was 25. I guess I just skipped over 24. I can always go back and do it. So I did 25, 23. Let's see, what was the answer to that? That was D. Okay, so I did 22, 23. I skipped to 25, and before I go on to do number 26, I guess I'll go back and do 24 for you as well. A little bit out of order, but no big deal. Okay, so for 24, it said the 9th term of the sequence. They want you to find the indicated term of the sequence. So they gave you 24, they gave you 19, they gave you 14, and they want you to find the 9th term of the sequence. Okay, so this is just me copying the problem from your practice test. And again, I'm telling you that the overriding formula in this section is the nth term. So you can use it to find the 9th term, the 20th term, the 5,000th term is equal to the first term plus n minus 1 times the common difference. And you can, this one's pretty easy because you can see everything just in the sequence. It's just the nth term is equal to the first term, which is that 24. And then it's just plus n minus 1 times the common difference, and the common difference from here to here, if you wanted to get from 24 to 19, you'd have to subtract 5. You want to get from 19 to 14, you subtract 5. So that common difference is negative 5. So you end up with 24. This negative 5 gets distributed to both of these terms here, so you'd have a negative 5n. Negative 5 times negative 1 is positive 5. So you'd have, let's see, 24 plus 5, 29, minus 5n. That is your formula for finding any term in this particular sequence. So if they said find the 9th term, then you're just letting n be equal to 9. So it would be 29 minus 5 times n. So 29 minus 45, and 29 minus 45 is negative 16, and I believe that's choice A for problem number 24. Yes, negative 16. Okay, I already did 25, so let's go to 26. I'm going to stop this video at 30. Okay, we're still in Chapter 12, practice, test, and we are doing the problems from section 2.2 or 12.2, and that is numbers 20 all the way up to 30, just so you know where to find the formulas. Okay, so let's see, number 26. Let me see what that problem said. Okay, so we got another one of these crazy ones. These are the harder ones. They tell you that the 7th term is 4. They tell you that the 13th term is 16. So what I was trying to explain to you in problem number 25 is that they've given you values in two different positions. They're saying that in the 7th position, you have this value 4. And then you're going to jump to the 8th, 9th, 10th, 11th, 12th, 13th. You're going to all of a sudden be in the 13th position. And in that position is the number 16. So as you go from to 8th position, 9th position, 10th position, 11th position, 12th position, 13th position, look at how many spaces there are here. There's 1, 2, 3, 4, 5, 6. So there's 6 positions between 7th and 16th. You could also look at how do the values change as you go from 7th position to 16th position. And you can just do that by taking the number that you ended up with. You go from here to here and go that number minus this number. Now sometimes one or the other or both are negative, so that, you got to be careful when you subtract. It's just this one where you end up minus the one you started at. That gives you 12. So I took 12 and I divided it up amongst 6 positions, which is 2, and that value is the D value. Just what I did in number 25. Okay, I found out how many positions am I moving through. And in this particular, and I think in number 25, it was also 6 positions as I went from whatever position to the ending position. Then I looked at the values. That's these right here. Ending value minus beginning value. And figured out, okay, so I've passed through from 4 to 16. That's a total of 12. And I'm splitting that up amongst six positions. That just lets you know that as you jump from 7th to 8th position, and from 8th position to 9th position, and so on, that you are adding 2, adding 2, adding 2, and that is your D value. Okay, so now you can go on with this problem, and in problem number 26, you can go on with this problem and go, the formula that's being used here is how to find a number in any position by using the first value in the sequence plus n minus 1 times the D value, which I just went through that explanation to help you find. Okay, so I don't care if you work with the 7th term or the 13th term, just work with one of them. I'm going to work with the one in the 7th position. So in other words, the 7th term. So a sub 7 is equal to, because remember they wanted us to find the first term and also to define a recursive formula. So with what I'm doing right now, I'm going to be able to find this. And once I find this, I can lay out the values of the sequence and find a recursive formula. I got to find a sub 1 first. So I'm using the value that's in the 7th position, the 7th term. So my subscript is 7. In other words, my n value is 7, and it is 7 here as well. Common difference, I went through all of this to explain to you how I got that common difference right there. Okay, so the actual value that stands for the 7th term, that's what a sub 7 means, is 4. That value is equivalent to the term in the 7th position. So you can put a 4 in place of this. A sub 1 we do not know yet. 7 minus 1 is 6. 6 times, or no, this is supposed to be n minus 1. What the heck I'm doing here? This is supposed to be n minus 1 times 2. So this is going to be 2 times d, or 2 times n, and then 2 times negative 1. I think I'm going goofy after doing so many problems here. All right, so it's the number in the 7th position is 4. That's the value. We're going to be looking for the number in the 1st position, and then this is 2 times n minus 2. Okay, so if you want to simplify this a little bit, I could have left the 7 in there. You can put 7 in there for n because that was the 7 that was here as well. And this will be 14 minus 2, which is a sub 1 plus 12. And then you can subtract 12 on both sides, and you get that a sub 1 is equal to negative 8. Okay. All right, so I had found the d value. I put the d value right there, and I went 2n minus 2. Because we are looking for the number in the 7th position, that means the n value is 7, so that gives you the right to put it right in there or in there. Doesn't matter whether you plug it in here or you plug it in there. You have to put that n value in so that you don't have an extra variable. So I chose to go 2n minus 2. I ended up dumping in the 7 in there, but then we actually knew the value in the 7th position. And that value was given right here. In the 7th position, there is a value that's equal to 4. So I dumped that in there for a sub 7, and then on this side I had a sub 1 plus 12. I moved the 12 over here. 4 take away 12 is negative 8. So I've answered this question. What is the first value? I can also use that value to lay out the terms of the sequence, and then I can come up with a recursive formula. So this would be the first term in the sequence. This is a sub 1. And then a sub 2, well, the common difference was 2. We had figured that out way up here. That common difference was 2. So if I just add 2 each time, I'm going to get to the next value in the formula. So you have negative 8, negative 6, and then if you want to add 2 again, you're at the 3rd term, which is negative 4. If you want to add 2 again, you're at the 4th term, which is negative 2, and so on. To give a formula recursively, it would just be any term in this sequence after the first term would just be, like if you were going to get this one, it would be the previous term. This is how you write the previous term. Instead of n, call it n minus 1. That means the term before this one. So if you're looking for this term, use the term before it and then add 2. And here you have a recursive formula for the numbers in this sequence. Okay, so that is number 26, and that choice was A. Choice A, you were offered this as well as this. Okay, that's 26. So I've done 25 and 26, and then in 27, in problem number 27, it's 12, 10, 8, and then it ends like this. They're telling you to go all the way up to a sub 26, and the directions read, find the indicated term using the given information. Okay, so we're supposed to find the 26th term. So we definitely have the first term, and we can definitely see what the common difference is. So you're subtracting 2 to get from here to here. Let's make sure that's consistent so we know it's an arithmetic sequence. And so we can see just from those first three terms that we're using the same common difference each time. So we can go ahead and again use that formula. Nth term, specifically we'll use it to get the 26th term, is always the first term plus n minus 1 times d. Let's put values in there. First term is 12. We're going to leave n in here and call this a formula for the nth term, meaning any term in this sequence. Common difference turned out to be -2. That's what you're looking at right there. And if we clean this up a bit, it would be 12. This would be -2 times n, -2n. -2 times -1 is +2. And this would be 12 plus 2, 14 minus 2n. So you can find any term in the sequence. They've asked us to find the 26th term. So 14 minus 2 times the n value, which is 26. This is 14. This times this is 52. And 14 minus 52 is -38. And I believe that answer is choice B. So that's for number 27. Okay, number 28. Okay, 28. They give you A is equal to -3. D is equal to -6 this. And then they say this time, they're just posing the problem with different notation, but they're really asking the same question. When they give you this A value in number 28, they're really giving you the first value. So when they just put A, that really means the very first value. It's just a different way of notating it. So back to that same formula, we are specifically looking for the 31st term. This will allow you to find any term, this formula that we're going to compose. And it starts off with the first term. Just keep writing the formula so you can memorize it. N minus 1 times D. First term was given as -3. Then we're going to go n minus 1 times the D value, which is -6 this. Okay, then as we multiply here, this is going to be -3. And then this is going to be -6/5 times n. And then -6/5 times -1 is +6/5. So you can put that in your calculator. You can add this to this and have your calculator simplify it. So it'll be -3 minus 6 divided by 5. And instead of hitting enter, hit math, enter, enter. And that's -21 over 5. Let me make sure that I did that right. Okay, so -3, this was -6/5. This is -6/5. This is +6/5. So, oops, I don't know. No, I think that's it. Let me add these two again. I wanted to add -3 plus 6/5. Plus 6 divided by 5. Hit math, enter, enter, -9/5. So, with like terms combined, it is -6/5 times n. And then when I added this and this, I got -9/5. So I can use this formula to get any term that I want. Let's write it a little bit neater over here without all the work next to it. And then proceed to find the 31st term. So 31st term is -6/5. N value, as noted here, is 31 minus 9/5. Okay, so this in the calculator would be negative 6 times 31 divided by 5 minus 9/5. Negative 6 times 31 divided by 5, and then minus 9/5. Minus 9 divided by 5, and hit math, enter, enter. It'll give you negative 39 as your answer. Okay, let's see, that is choice D, or no, choice C. Choice C for number 28. Okay, moving on to 29. Two more for section 2.2. In section 12.2, where we grab the numbers 20 through 30 from the practice test, and we're on number 29. So number 29, back to this summation notation. Give you 1 here, they give you 45 here, and it's 5n minus 3. Okay, you're still in the arithmetic formulas, and once you get to the summation formulas, then we have a brand new formula, and the formula for, now you see that it would be just ridiculous to try and plug in 1, then plug in 2, then plug in 3, all the way until you plugged in 45 values. So there's a quicker way to create that list plus add them all together at the same time, and that is by way of this formula. It's taking all the values that would have been generated if you plugged in 1, then 2, then 3, then 4, all the way up to plugging in n over 45, and it's adding them all together. That's what this formula is doing. It's summing them all together. Okay, so this is the sum of an arithmetic sequence. You must know the first term in the sequence, which is called a sub 1, and the last term in the sequence, which is called a sub 1, and we can figure that out. Okay, this is the first term, this is the last term. So if I wanted to find, do a little scratch work over here, the first term would just be when you're letting n be equal to 1 in this formula. So 5 times 1 minus 3, that's equal to 2. So there's your first value. If I want to know the last term in the sequence, well, that would be when n is equal to 45, but using this same formula. So it would be 5 times 45 minus 3, and 5 times 45 minus 3 would be equal to 222. So I know the first term and the last term, and I can now continue with the sum of all 45 terms, each one generated by 5n minus 3. Without actually writing out those terms, you can still sum them together. So it's going to be number of terms. In this particular sequence, there are 45 of them because you're spinning from 1 to 45, divided by 2, so says the formula, and then you take the first term, which we've already calculated, and you add it to the last term according to this formula. Okay, so this is going to be 45 divided by 2 times 2, 24. And you can just put all that in your calculator. 45 times 224, ultimately divided by 2. So 45 times 224 is this, divided by 2, and your final answer, all 45 terms added together that come from this particular sequence, is 5,040. And that particular answer was choice D on the practice test. Okay, moving to number 30, and we will end this video here. You have the same sort of setup. You're talking about 40 different values, all created from this formula right out in front of the summation symbol. Instead of listing all 40 and adding, I mean, you know, it's okay to list them yourself and add them together if you're only going through a few values, like from 1 to 4 or from 1 to 5, then that's fine. List them separately and add them together. But when you have just a whole bunch of values that would have to be listed, then you want to use the summation formula. So once again, we're going to use this formula to find the sum. N over 2. We need that first value. We need that last value. So we're going to come over here and do that. We're going to find the first value. In other words, where n is equal to 1 using this formula right here. Negative 2 times 1 plus 7, which would be negative 2 plus 7, 5. So that is our first value. Then we're going to find the last term, which is really going to be the 40th term. And that just means that n is equal to 40 using that same formula, negative 2n plus 7. Negative 2n plus 7. Okay, and this is negative 80 plus 7, which is negative 73. So that's your last value, or your 40th value. I'll write both here. Okay, so now coming back to this main formula where we were missing this and this, but now we have it. We're going through 40 different values here. So put 40 for n, that's the number of values that you're adding together, divided by 2. Then we'll put the first value in the sequence right here and add it to the last value in the sequence, which I've calculated here. So 5 plus negative 73 is the same thing as 40 over 2. And you can call that 20 if you want to. And then if you added 5 to negative 73, that would be negative 68. So you can pop that in your calculator. Just 40 times negative 68 divided by 2. And you get negative 1360. And that is the sum of all the numbers after you let this be 1, then 2, then 3, all the way up to 40, and have already summed them all together. And that was choice D for this particular value. Okay, that concludes video number 2. We've concluded up through section 2 in the practice test for chapter 12. I'll pick up again in the next video with the problems from section 12.3.